Okay, so what you have to do is you have to do this particular problem. Suppose x and y are IID uniform 0, 1. Okay, you have to figure out the joint PDF of x, y, and then you have to figure out expected value of x times y. Then you have to figure out the joint PDF of min x, y, and max x, y. And then you have to figure out the marginal PDF of min x, y. And then you have to figure out the conditional PDF of max x, y given that min x, y is equal to t. Okay, and then you have to figure out the conditional expectation of max xy given that min xy is equal to t. Okay, also let us do this problem, question number 7. Find the PDF of t, which is x plus y. Okay, so the first one is easy. Can you tell me what is the joint PDF of x and y? Anyone? Since x and y are independent, okay, so the joint is the product of the marginals. Okay, so first one. Okay, which is going to give you what? So it is going to give you 1 when x is between 0 and 1 as well as y is between 0 and 1, and 0 otherwise. Is that okay? For question number 2, either you can use two-dimensional lotus, okay, or you can use the fact that x and y are independent. Since x and y are independent, so the covariance between x and y is 0. That means expectation of xy is equal to expectation of x times expectation of y, and then you can just simply figure out what is expectation of x, and since x and y have the same distribution, so expected value of x is equal to expected value of y, and you will get 1 by 2 into 1 by 2, which is 1 by 4. So in order to figure out the joint PDF of min xy and max xy, the first thing that you can do is you can start with finding the joint CDF. Okay, so because once you have the joint CDF, then you can differentiate the joint CDF partially with respect to both the random variables min xy and max xy to get to get the joint PDF. Okay, so let me tell you exactly what I meant. So let L equals min xy. L is the lower one, okay, and H is the higher one, okay. So H is the max xy, okay. So the first thing to note here is this, that both L and H also takes value between 0 and 1. And another thing is that L always takes value smaller than H. Is that okay? Both L and H takes value between 0 and 1, and the other thing to note here is this, that L always takes value smaller than H. So the density will be positive. So the joint density will be positive over these values of L and H. Okay, so this is the support of L and H, right? The joint density will be positive over these values of L and H. The reason is because both L and H lies between 0 and 1, and the other thing is that L is always less than H. So I just have to find the joint CDF over these values of L and H, okay, and then do the double derivative of that joint CDF. Okay? So joint CDF, Okay, so I have to figure out what is the value of the joint CDF when L and H satisfy this. Okay, so let me just give you a picture. Okay, so let's just see. Notice that this is the support of X and Y. Okay, this is the support of X and Y. These are the set of values that XY takes. Okay, now min XY equal to L, min XY equal to L. How do you plot that? So min XY equal to L will look like this, right? Where this is L and this is L, right? This is min XY equal to L, right? And what is max XY equal to H? Max XY equal to H will look like this. Okay, so now let us see what is this. This is probability that L is less than or equal to L and H is less than or equal to H. So, so you want min XY to be less than or equal to L, which means that XY should lie in this region. And you also want max XY to be less than or equal to H. So that means max XY should lie in this region. What that means is the intersection will be given by this region. Do you agree this is the intersection? So we just have to find the probability that XY lies in this region. Is that okay? Because that's where L is less than or equal to L as well as H is less than or equal to H. Yes or no? Is that okay? So I just have to integrate 1 over this. Integrating 1 over this, because 1 is the joint density, right? So if you integrate 1 over this, that's nothing but the area of this, right? Integrating 1 over this is nothing but finding the area of this. So what is the area of this? Anybody? What is the area of this? So this is L square. This is L square. Okay, and this is H minus L times L. And this is also H minus L times L. Right? Yes or no? Have you understood this? Okay. So this is the joint CDF. Now let's figure out the joint PDF. Okay, so joint PDF will be the uh, double partial derivative, okay, first with respect to L and then with respect to H, okay, of the joint CDF. So F, so let's take its derivative with respect to L and then with respect to H. We are going to get 2. Is that okay? Yes or no? Do you agree we are going to get this? Take the derivative with respect to L, then with respect to H. Notice that this term does not have any H, so this will become 0 eventually. This term does not have any H again, so this will also become 0. So the only term that will not become 0 is 2LH. And it will become 2 because, once you differentiate with respect to L, L will go away. When then if you differentiate it with respect to H, H will also go away and you'll be left with just the constant 2. Is that okay? Have you understood this? Okay, so this is the joint PDF. Okay, this is what we were interested in. This is the joint PDF of L and H. So the next is to find the PDF of L. Okay, so how do you find the marginal PDF of L? FLL is equal to what? Integral of the joint with respect to H, right? From negative infinity to infinity, which will give you what? Which is like integrating 2 from L to 1. Is that okay? Because elsewhere it's 0, right? So elsewhere the joint density is 0. So, you can completely ignore that part. Okay. And you just need to integrate 2 over this region, L to 1. Is that fine? So you'll get what? 2 into 1 minus L. And this is for L between 0 and 1. And 0 otherwise. Is that clear? So this is the marginal PDF of L. Okay. So let us now figure out the conditional PDF of max xy given that min xy is some value t. Okay. Or let's make it L. Let's be consistent. Okay. Okay. So I want this, right? I want f right? Okay, so notice that this is nothing but the joint divided by the marginal of L. Okay, and this is actually non-zero. This is non-zero for these values of L and H. Okay, so what is it? So what is the joint? Joint is 2, right? Okay, joint is 2. And what is the marginal of L? When L is between 0 and 1, it is 2, 2 into 1 minus L. Okay, which will give you what? 1 upon 1 minus L. So you can also say that H given L equal to L is uniform from L to 1, right? This is uniform distribution, right? From L to 1. Because it's just going to be this, which depends on this constant L, okay? And it's a constant number, okay? So H, since the density is constant over L to 1, okay, so it's uniform distribution over L to 1. Is that okay? Now let us figure out the conditional expectation of max xy given min xy equal to L. So you just have to figure out expected value of H given L equal to L. Okay, so if you want to figure out the conditional expectation, you just have to use the conditional distribution of H given L equal to L. Okay, and since it's uniform, from L to 1, we know that uniform AB, the random variable uniform AB has expectation A plus B by 2. Therefore, expectation of H given L equal to L is 1 plus L by 2, right? Is that clear? Okay. Okay, now let us figure out the PDF of t, which is x plus y. So again, what we can do is we can start with the CDF. We can first find the CDF of t, and then we can figure out the PDF of t. Okay, so let me just first show you how to figure out the CDF of t. So this is the joint density, right? This is the support of the joint density of x and y. Right? So if I want to, so notice that x plus y, will only take values between 0 and 2, because x and y are IID uniform 0, 1. So x can only take value between 0 and 1, y can only take value between 0 and 1. So the sum of them can only take value between 0 and 2. Okay. So now if I want to find the joint CDF, so sorry, if I want to find the CDF of t, okay, it is nothing but probability that x plus y is less than or equal to t, right? Probability that x plus y is less than or equal to t. Okay, so what I can do is the following. I can plot this, how is this going to look? What kind of region that I need to do the integral over? Okay, so notice that if t is less than 1, if t is less than 1, then this is how it's going to look. T is between 0 and 1. So basically, if t is between 0 and 1, this is how this line will look. This is the line x plus y equal to t. This is the line x plus y equal to t. So I need to integrate the joint density of x and y over this triangle. Okay, I need to integrate the joint density of x and y over this triangle. Yes or no? Is that okay? So basically, what am I going to get? I'm going to get, because the joint density is 1, so it is nothing but the area of this triangle. Okay, so integrating 1 over this triangle will give you the area of this triangle, right? So what is the area of this triangle? Half t square, right? Yes or no? Right? Yes or no? Okay. And if t is greater than 1, okay, if t is greater than 1, then the situation will look like this. Okay. And in that case, I have to do the integral of the joint density over this region. Yes or no? This is if t is greater than 1. Of course, t is between 1 and 2, I should say. Okay. If t is between 1 and 2, then I have to do the integral of the joint density of x and y over this region. Yes or no? Yes or no? Over this region. Do you all agree? Okay. So how will you do that? So one way to do that is, you can again find the area of this, then find the area of this. You can just do that. You can also do the integral if you wish. One simple way to do this is basically, what you can do is you can find the area of this triangle, and that will also do, so area of this triangle. Okay. And just subtract that from 1. Okay, because the remaining is this. Okay, so that's another way to do it. So let's just do it that way. Let's find the area of this triangle. Okay, and subtract that from 1. Okay, so what is the area of this triangle? For that, I need to know this length. Okay, so now notice that this is t minus 1 and this is a 45-degree line. So this is also t minus 1, right? If this is t minus 1, this is also t minus 1. And this is 1. So what is 1 minus t minus 1? 1 minus t minus 1. What is it? Is it 2 minus t? It's 2 minus t, right? So this is 2 minus t. And this is also 2 minus t. Okay. So if this is 2 minus t, 2 minus t, so we are going to get what? 1 minus 2 minus t squared by 2. and this is if t is between 1 and 2. Is that okay? Okay. So let's just once we have the CDF, now we can actually figure out the PDF. So how do you figure out the PDF from the CDF? By taking the derivative. So let's take the derivative, and what are we going to get? This is t, and what about this? This is 2 minus t, right? Please check. Okay.